Welcome, this is Mr. TG. By now you've viewed a couple videos on section 2.1, so you should be familiar with the terminology in section 2.1 with relations and functions. Now what I'm going to demonstrate to you is ways in which we can write functions, referred to as function notation or function rule. And you can see from your notes that a function rule is an equation that represents an output value in terms of its inputs. You can write a function rule in a function notation form. This may cause some of you some problems, but so pay attention to the notes. As you can see in the first example here, the y is basically going to be your output. Usually we write it up to this point in time, you've written it, your equation in this form. We are now going to replace that with this notation. Now the letter you use is F in this case. You can use any small letter of the alphabet. Normally we use F. You can use H, you can use G, but as read as f of x is equal to 3x plus 2. Please keep in mind that the y and the f of x essentially mean the same thing, and that's the output. Now what we're going to do here is show you, and then one other thing before I show you some examples, the independent variable, the x, is always going to be, well, the x, this part right here, and the dependent variable is going to be always your y. That's what your output's going to be. Now, what they will do to test you on this is they will give you problems, and in the directions of the problems, they will basically give you some equations. And notice each of these equations are given to you in function notation. This one here is f of x equals 2x plus 3. Then they call this one g of x. They're just simply labels. Remember, the g of x in this case, again, would be the output or the output or the range. And this one is quadratic. That's equal to -3 plus 2x minus x squared. And of course, h of x is provided below. Now, what they'll do is they'll give you this instruction, find each. And they'll simply say find, it's read as f of -4. What this means first is you identify the function that they want you to use, which is right there. And you write, and you're basically going to put -4 in for x. And when we do that successfully, make sure you put parentheses here, you will end up with an equation that you have to solve on the right hand side. This basically will give you your output when f is -4. It's called f of -4. If we do this successfully, we'll end up with a -8 plus 3, and that's a -5. So we read this as the way as following. F of -4, when we're putting a -4 in, our output is -5. Again, in problem number 2, you're looking at h of -2. Here's, since this is h is right here, we could actually, if we want to simplify the function first, it might make our job a little bit easier. So as you can see, h of x can be simplified because we have a couple like terms here. So we would say h of x equals 20x minus 7. And then you're going to insert the -2, remember, is your input variable. So that turns into this, h of -2 is equal to 20 times a -2 minus 7, which gives you a -40 minus 7, which is a -47. That becomes your output when the input is -2. Now, what I'd like to have you do is make an effort to try number 3 on your own. Basically, I'm going to erase all this work here, so make sure you have all this listed down, and then we're going to make an effort to try and have you put in a -2, excuse me, -1 into the g function. So hit pause and give yourself a chance to do. Welcome back. Hopefully you were successful, but let's take a look at number 3. Again, we're inputting g of we're putting a -1 into the function. This is how that looks. Remember, this is read as g of x equals -3 plus 2x minus x. in this particular setting, we are going to put the -1 in two locations. First in the x, and then secondly in this x squared location. So we want to make sure we put or replace this not with x, but with a -1. So we're going to put a -1 there, and then you need to put parentheses here, because we want to make sure we square both the negative and the 1. Then it's just a matter of simplifying using PEMDAS, the right-hand side. So we end up with -3 plus a -2 minus 1. Now this is a little confusing. The minus is not squared, so that stays with us. The -1 is squared, so that becomes a +1. And then we simplify these two, -5 minus 1, that's a -6. That becomes your output when your input is -1. The only thing different about this, other than the fact that we're using a different function, is that we're inserting the input -1 in for both variables. The textbook may not put it in this form. They may just say let x be equal to a -1 when you're doing your assignment, and it means the same thing. So hopefully that went well. Now let's apply this function notation to an application problem. And it says here, write a function to model the cost of a long distance cell phone calling plan. Then evaluate the function for certain given values in minutes. Well, what we have here is a monthly service fee of $4.52. And then we're being charged 12 cents per minute. So a function that you could use here, first of all, your variables, I'm going to call minutes. Let's just call that M. So identify your variables. And then, of course, you're looking at cost. I'm going to call that, I'll just call that C. So use variables that makes it easier for you to remember. So here's my function rule. The cost of my plan will be equal to 0.12, 12 cents, times the number of minutes that I call, plus that one-time fee, monthly fee of $4.52. Okay, as you can see, it is now a function rule. We can call this, and if we want to modify and using the current notation, we would call this C of x, x being your input, equals 0.12 times x plus 452. That basically is, and up here this would be C of M if you use M for minutes. So you can write it as different ways. The first one here, and I'll just make this a little larger for you. This here can just be listed as C of M, the function of the cost. As you can see, it'd be C of M equals 0.212 times the minutes plus 452. Or you can use x2, it doesn't matter. Now, what happens with this if we actually start putting values in? I wanted to show you what we'll be experiencing as we get into later sections in this chapter. What's going to happen here is this. Excuse me. You can input values, get your outputs. There's my rule. And like, for example, I put in 0 minutes. Well, obviously, we don't use our plan. 0 minutes is going to cost us $4.52. And I just went by fives and put 5 minutes, 10 minutes. And I wanted to show you, first of all, what happens when we put these values in for minutes and generate the cost. And so what we're essentially doing is putting all these numbers in for x, figuring out what our cost is. This is your C of x. This is your x. C of x. Now, the cost, we referred to that earlier as the dependent variable. The cost is the dependent variable because it depends on how many minutes we call. You always want to get used to putting the dependent variable on your y-axis, and your independent variable will always be on your x-axis. This is going to be mostly time. Time is most often the independent variable. Now, this function that we're using here is called a linear function. And the reason it's a linear function is because, as you can see, we're increasing our cost at a constant rate. As the number of minutes increase, our rate increases, our actual cost increases at 12 cents per minute. Anytime you have an increase that goes up at a constant rate, you have a linear function. So what I did was I plotted these points ahead of time, and you could see how they formed a line together. So we'll be working a lot with linear functions in this unit, along with quadratic functions. So in review, this is nothing different than what you're used to before, but we're looking at function notation and function rules, what independent and dependent variables are. It's really simple. You just have to get used to the different ways in which they can write it and read it appropriately. Use this top paragraph as a good way of representing, as you can see, f of 1 is the output when 1 is the input. Remember, on the right side we have the input. So hopefully this made sense, and good luck with this lesson. Thank you.